Good afternoon, everyone. Today we are going to discuss about the topic is E1 and E2 mechanism. In this mechanism, in this reaction, we are going to prepare alkenes. Alkenes are carbon-carbon double bond is called as a alkenes. For the preparation of alkenes, we took alkyl halides in which we add a base which extract halide ion and H positive ion to give us a compound called as a alkenes. This reaction is also called hydrohalogenation. In this reaction, we are eliminating a hydrogen and halogen. Now, next, the mechanism is consists of two types. One is called as a E1 and other one is called as a E2. E1 stands for a elimination reaction, unimolecular, while E2 stands for elimination reaction bimolecular. So we are going to discuss about this. First we will take an example of E1 mechanism. In this mechanism, the alkyl halide, it is a unimolecular mechanism. The alkyl halide having a bond that is a carbon and halogen. We know that halogen is more electronegative, is attract electron towards itself, so it take a partial negative charge, while carbon get a partial positive charge. As this reaction, as this molecule, this bond is a polar in nature, so this elimination occurs. This is a step number one, where the halogen carries a partial negative charge, the corresponding carbon carries a partial positive charge. As the halogen is more electronegative, there is a heterolytic cleavage. The halogen comes out with its electron as a halide ion, and this carbon carries a positive charge. There is a formation of an intermediate called as a carbocation. This is the first step mechanism. This is the first step, and this is a slow step. This step is a slow step. Now the second step, the carbocation which is formed. Second step, the carbocation which is formed, the corresponding carbon which carries a hydrogen, the base will abstract this H as a proton, and there is a formation of a carbon-carbon double bond. And this step is a fast step. This step is a fast step. As we know that the rate determining step is always a slow step. As we know, the slow step is a step number one, where the reagent is a 1. So the rate of reaction is depends upon the concentration of the alkyl halide. This is a one reactant, so we can say that it is called as a unimolecular. Now we are going to start with a next mechanism which is called as a E2 mechanism. In this mechanism, the alkyl halide is approached by a base. The base, it will abstract a proton from this side. The proton comes out to make a H2O, while this carbon carries a lone pair of electron, and it carries a negative charge. Now there is a formation of intermediate called as a carbanion. There is a formation of a carbanion. This is a step number one, and this step is a slow step. This step is a slow step. Now the second step, the carbanion formed in a step number one. Step number one, the halogen will come out as a halide ion, and there is a formation of carbon-carbon double bond. Here, this step is a fast step. As we know that rate determining step is always a slow step. Here, slow step is a step number one, which has a two reactant, alkyl halide and a nucleophile. As there is a two reactant, so the rate will depends upon the rate is directly proportional to the concentration of alkyl halide and the concentration of the base, that is a nucleophile. Here these are two reactants. So this reaction is called as a bimolecular mechanism. So E1 and E2, E1 is called as a unimolecular, while E2 is called as a bimolecular mechanism.